Alright, we're going to call this one Facts About Correlation. It's in section 3-1. Okay, so we know if someone is tall, then they probably, not definitely, but they probably weigh more than average. Which means that height and weight should have a positive correlation. On the other hand, you would think the amount of time studying and wrong answers on a test, as one goes up, the other one goes down, so you would hope that would have a negative correlation. Alright, so we'll start out by talking about different things about correlation. Correlation doesn't care about explanatory and response. So if I was doing a look at SAT math versus verbal, and then I turned it around and decided to do, and it said R was equal to 0.7. If I did verbal versus math, R would still be 0.7. Number two, R doesn't change if you change units. So if you do height in inches versus weight in pounds, and some British kid comes over and says, what are inches and pounds? And you change this to be, okay, we're going to change this to be height in centimeters and weight in kilograms. R will stay the same. The third one, R is positive for positive association. And guess what? And it is negative for negative association. Okay, R always has to be less than or equal to 1 and greater than or equal to, I'll move this away just for right now, -1. Okay. If you are close to 1 or -1, it is strong. If it's close to 0, it is weak. Okay, these are what we call the cautions. The first caution is that we need 2 quantitative variables. We cannot do this if one of the variables is gender or ethnicity. They both have to be numbers. Number 2, it measures strength in linear relationships. Three, it is not resistant to outliers, because one outlier can change everything. And number 4, it is not a complete summary. It's just one aspect of what's going on. In order to do that, you may want to graph the points or look at the best fit line and many other things. But this is not a complete picture. Alright, so last thing we're going to talk about is Siscoe and Ebert's reviews. Basically had an R equaling 0.8, which is pretty strong. But Siscoe's mean was 3.2 stars and Ebert's mean was 2.8 stars. Is this possible? And the answer is yes. That basically Siscoe and Ebert would agree that a good movie is better than, and a bad movie got worse stars, so they very much agreed what a good movie is and what a bad movie is. It's just Siscoe was an easier grader than Ebert, because Ebert gave a lower amount of stars on general than Siscoe. But for the most part, they agreed that one movie would be better than the other. And that's going to be it for our video on correlation.